Okay, I do not object. Okay, welcome to our first Weather Watch of 2021. Thank you, Pete, for organizing this. We're now using Zoom as our platform and learning how to do all of that stuff. So, and for those of you in 753, this will be the first time you're joining the weather discussion for the semester for your class. And then hopefully anybody else who's interested is joining as well. I didn't really have a good place to start to insert this diagram that I'm showing you to begin with. This is the 850 millibar -5 cold pool area for this current winter, 2021. So the red line is the daily aerial extent of the -5 air in the Northern Hemisphere at 850 millibars. And then the gray shading that's bounded by sort of thick dashed blue lines is the plus and -1 standard deviation, which is above and below the solid blue line, which is or the thick blue line, which is the daily average. And then the thinner blue lines that are going north and south on the diagram are the all-time maximum and min for each calendar day. So you get a whole bunch of information on this thing all at once. And those thin blue lines are at the suggestion of Michael Morgan. I'm really glad he suggested that. That's an excellent addition to this diagram. So and then the red line is the daily time series of the 850 millibar -5 cold pool aerial extent for this winter. And you can see that we're well below the average almost every day of this winter. This goes through January 28th, as it turns out. Almost every single day of the year, we're below the average. There's maybe 6 or 8 days max where we've been above it. And we've been hovering around 1 standard deviation below the average for a good part of January. I'd say almost half of January, with a few excursions recently towards the average. When you integrate this over the whole season and then compare it to other seasons, we are currently the 11th warmest winter, December 1st to January 28th of the last 73. And that's from the NSEP analysis combined with a few years of GFS 1 degree data. So it's pretty confident that we're right in there. 85th percentile of warmest winters of all time in the Northern Hemisphere, at least in the last 73 years. So I didn't have a better place to show this, so I started off the discussion with it. And Stan Benjamin, of all people, genius at NMC, wrote to me about a week ago and said, where are we with this thing? So somebody actually is almost a fan of this 850 millibar cold pool. That made me feel really good. Stan, if you happen to be listening, which I doubt, thank you. It made me feel like it was worth keeping track of this. So that was pretty neat. Okay, so let's go away from the cold pool and think about this beast of a storm that is raging over the North Atlantic. So here's the satellite movie over the continental US and adjacent waters. I think the focus on the Atlantic on this particular GOES 17 is easier anyway. So we see this beautiful storm raging well offshore. It's not affecting really any land. Maybe Sable Island has strong winds and some precipitation, but everywhere else, even including most of maritime Canada, no particularly strong impacts from this event. But you can see it's a gorgeous storm. I wish I'd had a longer satellite movie of it to be able to show you. But even in these last 12 hours, you can see an absolutely gorgeous structure there. The thin cold frontal spine to the storm is very obvious. It stretches all the way from the main cloud head back down to Dominican Republic and Haiti. And then off the map, there's obviously some sort of warm frontal cloudiness that's extending farther to the east than you can see. And then there's some precipitation in the western side of the storm where were it over land, it'd be snowing like crazy in that location. Probably is over the ocean, or a mix of rain and snow. Probably 50 to 60 foot seas under this thing. The sea level pressure is down around in the mid 950s at its lowest. It may not be there anymore, but it's gotten down to a really intense disturbance. And you'll see when we look at some information from the GFS model in Viz 5D that goes into a forecast mode, there's another disturbance that's getting itself organized as it comes off the coast of New England. You can't really see that obviously in this infrared satellite movie. The only telltale sign is the extraordinary stratocumulus that's being formed as the cold air pulses off the coast. Watch, especially at Long Island. I'll get the cursor out of the way. There's a pulse, boom, a puff of stratocumulus, then another one comes right here. Boom, is another one. So there's pulses of really cold air coming off the coast. Yeah.
John, this is Michael Morgan. The other interesting thing about that is just to the north and east of that pulse of cold air, you can see the cloud tops getting colder. And this is a very interesting feature that showed up in forecast over the last, I think, 4 or 5 days. The models, particularly the NAM and the GFS to a lesser extent, has forecast a very intense trough or shear line to form just in that vicinity and rotate southeastward with heavy snow in it offshore. And some of the models actually closed off a very tight, probably 50 to 60 kilometer wide diameter cyclone along that shear line. But the models now just have a very sharp trough. We'll see that in the forecast. I can point that out. But I think where the clouds are getting colder is where that shear line is developing.
That's really interesting. And you'll see when we go to the 500 millibar map, there is a really intense cold pool sitting right over southern New England at 500 millibars. Temperatures are around minus 40. I don't know if it's Burlington or if it's in over the Cape, but it's extremely cold at 500 millibars in a very local regions. It's undoubtedly one of these tropopause polar vortices is getting itself involved on the far western side of this main extratropical development. So it's a complicated scenario up over the northeast part of North America. And you're pointing out that aspect. I can't wait to hear what you have to say about that. Then let's looking at the eastern half of the United States, largely cloud free. We have some high clouds over us. The sun is trying to poke through. It's not succeeding, but they're not, and they're going to get thicker as the day wears on. Then there's some unsettled weather over the Intermountain West. And then we'll have something to say about this major event that hit California and the far western states this week. It was a whole week-long event, and it's now relegated, at least from San Francisco down to the Bight, it's now relegated to convective showers underneath the coldest air aloft at 500 millibars. But it had been a plume of tropical moisture just being raked over the Sierra. Some 10 feet of snow at Mammoth Mountain and some other places in the Sierra. So pretty incredible event. And we'll see some elements of that. But I'm going to concentrate first on what's going on in the East Coast and then come back to the East Coast event near the end if I have time. So let me show you the sea level pressure from the GFS. It's valid about now, 18Z. And I'm not going to make you count these isobars, but they're every 4 millibars. And I think I counted them earlier. I think we're down at 956 or 960 for that one that's right near the cursor. So that's the intense minimum in sea level pressure associated with this cyclone that we just saw on the satellite. Here comes a pool of extremely cold air. The blue dashed lines are thicknesses. All the blue ones are below 540 decameters. All the red ones are above. And so we're in the, I don't see a label on these, unfortunately. I can't read it quickly anyway, but this is really cold air, and you'll see evidence of that at 500 millibars. And looking at just the thickness field with this intense of a storm, it struck me that this doesn't have an obvious occluded structure. And so I decided I wanted to see, I'll do a little bit more thinking about that and some analysis of the data. Here's Alicia Bentley's 850 millibar theta E at the same time. And boy, that's clear this is not an occluded structure. Here's the cold frontal boundary. The warm front's intense, and I'll show you later on in the middle of this intense disturbance, not only at 850, not only at 700 millibars, absolute absence of an occluded structure. It looks like a Shapiro-Kaiser cyclone. And Poshali Ghosh and I are working with Catherine Naud at City College in New York. We're trying to do some work on satellite remote sensing of the cloud canopies in occluded quadrants of storms. Step one was to develop a somewhat objective method, I think pretty objective method, to try and identify occluded structures in gridded analysis, objectively. And one of the things we stumbled upon quite by accident was that we think we can also identify Shapiro-Kaiser cyclones. And I'm wondering whether or not this one fits the bill, but it sure looks like it in a lot of other ways. Meanwhile, downstream, about to hit the British Isles, is a fairly intense cyclone that has a much more obvious occluded structure, a thin thermal ridge that goes right into the cyclone. So there's all manner of different things going on in the Atlantic and the North Atlantic today. It's quite interesting. I was going to then show you some stuff from GEMPAC, but I saved that for the Viz 5D part, so that's not a problem. I think instead.
So John, while you still have that map, or if that map is still handy, also note to the west of that cyclone, that trough, that inverted trough-like structure that extends out there.
Yep.
That's precisely where we're seeing the colder cloud tops beginning to develop.
And it's not unconnected to a thermal structure. Look at the little S shape in the isotherms. So there's something like a little wave developing far on the western side of this thing, and we'll see why when we go to 500. It's unmistakable why. But the close proximity is a curious aspect of this fairly active Atlantic cyclone situation right now. Instead of showing the surface obs themselves without much annotation, I decided I would show the 6-hour GFS forecast over the continental US just to outline the main features of interest synoptically over the continent. One of them is an anticyclone, which is responsible for us getting to and below zero the first couple of days of the whole season so far. We had -7 2 nights ago, was it, and -4 the night before, or it might have been just last night and in the night before that. Anyway, in the wake of our beautiful fresh powdery snow the other day, Monday and Tuesday, we've gotten down below zero in only the first 2 times of the year, and that's a consequence not only of the snow, but of the absolute windless conditions underneath this anticyclone, which is sliding off to our east now. And the next feature that we have to contend with is this broad surface trough and broad region of warm air advection that's just beginning perhaps to be felt outside at this hour. I think early this morning we were still on that warm advection was still west of us. Now it's starting to encroach. And so I think we're going to be seeing a warm up, but that warm up is associated with the encroachment of this storm. And I think we have some interesting weather to talk about for the weekend when we get there. I'm intrigued by the fact that there's so much precipitation in the short-term forecast on the western side of a disturbance that has a counterclockwise rotation. I don't really think I get that as part of a synoptic signal. It's probably instead related to the broad panoply of flow that's coming off the Pacific Ocean, not so obvious at sea level, as is often the case. In fact, it's given rise to this sometimes annoying insistence that atmospheric rivers are independent phenomena from cyclones, and that's a big part of the water budget in California. There's no disputing that features that happened like the one this week are a huge part of the water story in the southwestern U.S., but they almost always have some association with upper troughs and various other structures that are more canonical, not so mysterious. But this is an interesting case, and we're just seeing the last vestiges of that major winter event over Southern California right now in this map, and we'll see when we go to subsequent features, subsequent maps, you'll see the same thing. I think the next thing I look at is one of those subsequent maps, and that's the radar over the continental U.S. Very little precipitation falling anywhere in most of the eastern half. The exception is right in the Massachusetts Bay, Gulf of Maine, and that's in that association with that feature that Michael brought our attention to, both in the satellite and in the 850 millibar map. There's a development going on over the relatively warm water, and I think it's a consequence of extremely cold air aloft and cyclonic curvature. So we'll see how that's all put together, and Michael's going to be looking at that in some detail. And here are the last few convective elements, or the first few convective elements, coming on shore over the Bight and north of the Bight towards San Francisco that are underneath that cold air aloft that we'll see at 500 millibars. And then much of the rest of the heavy precipitation that has plagued the Sierra Nevada and southern Nevada itself over the last actually several days is beginning to wane as the flow is arranged so that it's more southerly as opposed to southwesterly, less moisture laden as a consequence. So pretty nice day across much of the country. Recovery at low and high elevation in California is underway. There's some flooding and mudslides. I saw a picture from Salinas where people have, 3 feet of mud in their living room. And the Salinas Valley, I mean, that's not a place where you expect you're going to get something like this too often, and they sure did this time. So bad event. Okay, and here's the satellite movie in the West Coast itself. It's too bad, again, we didn't have a longer view of this, because what looks like dilapidated cloudiness mostly over the Intermountain West was not so dilapidated yesterday or the day before. In fact, a little hint of that is right this piece of the cloud mass in the beginning of this 12-hour movie. You'll see moving along the Northern California-Nevada border. That is still quite coherent. And that's what that whole structure looked like yesterday and the day before as it made landfall. So extremely heavy precipitation at low elevation in the form of rain, at high elevation in the form of snow. And you can see the upper trough is indicated by the presence of the open cellular convection here just north of the Bight. And we were seeing that on the radar just a second ago. And here's another pretty intense disturbance just up near the Kodiak Island, Kenai Peninsula part of Alaska. And it's got its feet to the east. It's got precipitation and cloudiness all the way down almost into the subtropics in the Central Pacific. Here's Hawaii. So this has got some connection. And then coming across the Aleutian chain is the gradual development of this cyclonic disturbance. I think we'll see at 500 millibars. This is yet another upper level cold pool in association with some cyclonic curvature. So there's a lot of activity in both of the ocean basins adjacent to the coasts of the United States this morning and this week. It's been quite interesting. So with all that in the background, let's go to the upper level observations and take a look at that for a second. I like to start at 500 millibars. There's no particular reason except that I just like to see structures that look a little different than those near the surface. So here's 500 millibars, a couple of really features of interest. I want to zoom in New England. Look at some of these temperatures. Albany, New York, minus 40, minus 38 at Providence, minus 41 at Portland, Maine. This is exceptionally cold. Now, of course, it's January 28th or 29th. It should be exceptionally cold occasionally, but look at the scale of this. This is a little cold pool. I'm guessing that the TPV people down in Oklahoma, Steve Cavallo and his crew, are looking at this and saying, yeah, this is one of those tropopause polar vortices, small scale, locally cold only, not widespread cold, very interesting structures. And look at the cyclonic vorticity associated with this thing, and it's right off the coast is where we're seeing that development that Michael's going to tell us a little more about. And further to the east is this quite dilapidated looking upper level structure that is associated with our beast that's spinning around and had visited the 950 millibar range. And you can see, I know the pictures here are a little bit in my way. I'll just make the point by moving them. You don't see any thermal ridge coming back towards the center of this geopotential minimum. Again, indicative of the fact that this is not a canonically occluded cyclone. Even though it might have an element of that look on the satellite, it does not appear to be so when you look at the thermal structure. And then back to the west of this local cold cutoff over southern New England, we have a broad region of cyclonic shear and cold air advection, geostrophic cold advection. So I think the tropopause is being depressed on a line all the way from Green Bay down to about Atlantic City or south of that, maybe Dover, Delaware. So that's a region of pretty nice tropopause troughing at upper levels, I'm pretty sure. Back off the west coast, here's the bite of California. Here's the coldest air aloft. It's like minus 32 or something just to the southwest of San Francisco. And we saw evidence of that in the convective showers that were off the coast. And you can see how the flow now is more broadly off the northern states of Mexico, the Baja, not so much off land as the trough has moved ever so slightly eastward and changed its tilt just a little bit. It's almost a neutrally tilted trough now. It had been slightly positively tilted. So all of those factors have contributed to the cessation of much of the precipitation in the high terrain of Sierra, but not before some substantial damage had been done. In fact, let me show you that. Here's from the Weather Channel snowfall forecast. This was from this morning, early this morning. So it's Tuesday night to Friday. I think they're thinking about what's it actually going to look like. Mammoth Lakes and Mammoth Mountain were in the 10-foot range of expectation. I think they've currently accumulated 78 inches of snow or 79, something like that there, and they have a little bit still coming down. So another famous event in December of 2010 is one that many people who watch the snow in the Sierra have been comparing this one to. And there were local amounts in that December 2010 event that were greater than any local amounts from this one. However, the widespread nature of the heavy snow in this case, I think far exceeds that occurred in December 2010. So the total amount of snow that fell out of the sky, it probably was bigger in this event than that one. And you get an idea that this is a lot of water in the bank for agriculture in the Imperial Valley. That's a good thing for California and the nation. And we hope that we don't get a warm event that washes it all away between now and March, April, and May. This is it's nice to get this water in installments from runoff and not in one deluge. So hopefully that will be the case. But at least it's in the bank today. So let's go to another level besides 500 millibars. Oh, I just want to point one thing out about that. We saw the new development occurring just to the east of the Aleutians, and that's associated with air that's at minus 32 as well over the Gulf of Alaska, the western Gulf of Alaska. It's also got a little bit of a cyclonic curvature feature associated with that cold pool. So you've got low stability, cyclonic vorticity advection, presumably by the thermal wind as well as just at upper levels. And that's driving some development in the western Gulf of Alaska that we could see on the satellite. So let's go to 850 millibars, a little closer to the ground. Here's the structure of our storm off the Atlantic coast, not the new one that's developing, but you can even see there's the little troughiness just to the south of Nova Scotia. Extremely cold air. It's minus 28. I'm going to zoom in. The analysis is minus 28. I see the coldest temperature I see actually observed in the RAOBS is minus 23. So maybe it's not quite as cold as the analysis, or I'm misreading that number, but that's really cold at 850. And here's a little trough. And here's a little trough that's just in the Gulf of Maine, and that's going to be the next disturbance of interest. Look at the warm advection that's set up over the Central Plains, and we're not yet the beneficiaries of that. We're just about to be. This is from 12Z. So very strong temperature contrast with flow across it from the southwest. So it's going to warm up, and differential warm advection gives rise to ascent and cloud production. And so that's what's the harbinger of our next event Saturday night into Sunday. And then the widespread active regions of low pressure at 850 don't really show any of the thermal structure that you saw at 500 millibars. That's not surprising, but it's always of interest. With the structure of this main storm off the Atlantic, it's always hard to maintain a cold front over the warm central Atlantic Ocean. That's not surprising. The warm front is maintained or intensified simply by two things: strong frontogenetic action, and it gets colder to the north. So they're both working in favor of intensification of a warm front. Something about the large scale flow here is prohibiting this cyclone at upper levels from cutting itself off and really developing a classical occluded structure. It may be the lagging disturbance to the west that's helping to do that. I don't think that's the whole story, but anyway, that's one of the interesting things about this event that may lend it towards producing this Shapiro-Kaiser type structure, which I think we're seeing in it. Then I just wanted to show one thing. I've got some kinks to work out here. We just had a system upgrade on my main computing machine, and so some of the scripts that run my daily QG Omega weren't working automatically. So I did this one by hand. This is from last night. Let me make sure of the time. It's it's from this morning 0Z. So here you're looking at 700 millibar quasi-geostrophic Omega over the Atlantic Basin from 0Z. This is the storm out to the, it's north of the Azores, that's out to the east of the main development that we were watching. These yellow lines are upward vertical motions approximately every microbar per second. It's decipascals per second. So we've got extreme, it goes beyond the contour interval in the ascent region just off the Carolina coast for that development at 0Z. And here's the second development associated. The dashed white lines are 500 to 900 thickness. So there's a cold pool and some cyclonic curvature, and you get a nice couplet of upward and downward motion. And that's tied to what we're seeing over New England. But that's the main storm. And there's this active storm to the east. I wanted to go to a different time, maybe ahead to something like 18, which is more like right now. Our big storm is falling apart. Our secondary storm is starting to take on a little bit more intensity in terms of its couplet of vertical motion. And that is, I think, going to be a forecast issue that Michael may touch on in the forecast.
Hey, John.
So, yes.
I didn't really have much planned to say about this other than some of the things that I mentioned, but with that map that you have up here now, so that significant ascent that's occurring, this is what, 700 hectopascal?
Yeah.
That occurring over the warm surface, and we know there's a pressure trough there as well, maybe hydrostatically related to the thickness ridge. That's a lot of vortex stretching there that's going to spin up vorticity in that region. So it has all the elements of a cyclogenesis event, except it doesn't have really much direction to propagate, except perhaps get affected around the main storm.
Yeah, that's right. You're so right about that. Where's it gonna go is its question. I don't think I know the answer to that, but yeah, it's got a beautiful couplet of almost symmetric couplet of vertical motion, and right in the region of curvature of the vertical shear flow. So it's perfect. It's just where it should be. It's just got this miserable obstacle out in front of it. That's the raging storm to its east, and there's not much it can do about that. So it's a really interesting setup. And I won't spend any more time on this, not because I'm expecting you to, but just because I don't want to go too much longer in the discussion. I do want to show a couple things from Viz 5D. But this kind of insight that you can get at a glance from some of these things, or at least I shouldn't say insight. What I should say is instead, when you look at these things and they're somewhat unfamiliar, what it does for me anyway is it prompts me to ask some questions I wouldn't have thought of. And so that makes me almost always the curiosity-driven research that I'm entitled to do here and that I've enjoyed so much is based on this kind of thing, looking at the daily weather and then saying, boy, I don't understand what's going on there. Or like Michael's and Greg and I were talking about, I don't want to steal his thunder, but there's something about to develop off the Carolinas that used to happen seemingly all the time. But how does it work? And why doesn't it happen so frequently anymore? These are great questions. So I enjoyed looking at those kinds of things. So what I want to do now is say a couple of things about what I saw in this cyclone in the Atlantic from Viz 5D. And let me make sure I can clean up my page a little bit for you before we start looking at it. Okay, so this is from the GFS forecast from last night. I always like to let it spin up a little bit before I start showing stuff on here. So here's the sea level pressure. You can see hopefully continental North America in the United States outlined there. And then here's North Africa and the Horn of Africa. There's Iberia and the British Isles, Iceland, Greenland. So here's the storm out to the east that we had only mentioned. Here's the main storm of the event. And this was last night. This is actually the second image. Let me go back to the first one. This is last night at 6 p.m. or 7 p.m. for us. Okay. So then I put theta E on top at, I think it was 800 meters above of the surface. And so I've zoomed in, so hopefully you can see that okay. But there's a really obvious baroclinic zone that connects the warm front of the main storm just off the east coast to the cold front of the storm to the east. And notice there's a thermal ridge in this storm, looks kind of occluded even at low levels, which is unusual. And then here's the cold front that goes down across the Caribbean, south of Florida, and then maybe even has some coherence all the way into the central Gulf of Mexico. And then here's a secondary baroclinic zone to the north of the cyclone that is probably the breeding ground for this next thing that we're going to be talking about. So if I step forward, these are every 3 hours, you can see really nice warm frontal structure, really nice cold frontal structure, and something going on the northwest side of this thing, but no obvious thermal ridge yet. Keep on going. Oh man, look at that. Here's the warm front. Here's the cold front, and it looks like it's this T-bone structure that Mel Shapiro and Dan Kaiser talked about when they did the analysis of the Erica storms, which were formed in the same place in the same time of year. I think the first one was January 4th, 89 or something. But this is a really nice cold front and warm front, and they're fractured. So I want to try and zoom in a little bit more on that. And I'm going to translate it somewhat so you can see it. Oh, no. I got to start again. Rats. I'm trying to use all these buttons the way they're supposed to be used. Okay. And then translate. One more time. This time I'm reading the instructions. Okay. So there's our structure right in the middle of the page. There's the cyclone. At this time, it was down at about, according to GFS, this is a little smooth, so they always look a little less intense. This is 972 or high 960s, warm front, cold front, and the 800 meter theta E. If I show you the theta E at levels above this, because you could say, quite right, you could say, maybe this isn't the right way to look at, or the right level at which to look at the theta E, and you might be confused a little bit about what you're seeing. So I'm going to move it up to, say, 850. And I'm going to get the sea level pressure out of the way for you. Or the way I'm going to do that is I'll just keep sea level pressure below 1,000 millibars in place. So this is at 850. And I'll take that out just for the second. It still doesn't look occluded. Here's the cold frontal structure. Here's the warm front. And they connect like this T-bone. And then there's some sort of warm seclusion back here. But it's not really an occluded structure at all. And let me keep going on this just for the fun of it. So that's at 850. By the time you get to somewhere like 700 millibars or so, actually, let's go to 800 millibars, something like that, one still doesn't see an occluded structure. So this is really interesting. It's not that it's unprecedented. It's just that, I've not really paid attention to these things in any way. I'm going to make sure I get to the right level. Yeah. And we'll go all the way to 700, which is another level where I like to look at the thermal structure in theta E to see whether or not I see an occlusion. And I do not see that in this storm. It's really quite clearly to me more like a Shapiro-Kaiser cyclone than it is an occluded cyclone, classically occluded cyclone. So I found that interesting. I don't have time to show a lot more. And in contrast, look at that occluded thermal ridge in the storm that's off the Atlantic coast of Europe. That's very obviously different than this one to me. And I think if we looked at vertical cross sections through here, you'd see something that resembles an occluded structure. You'd really be hard pressed to find one here. And here's the cold pool aloft that's associated with the new development that is going on off the East Coast. And the last thing I'll say is, let's just look at the PV. We'll go back to the beginning. How do we do that? We'll go like this. Yeah, that's the beginning. So And I'll put the map at the top so you know where we are. Okay, so there's the map. Hopefully you can see it. Here's southern New England and Maine. And then here's the upper feature associated with the main cyclone. And I can bring that sea level pressure up to the top as well. There's our cyclone. And then if we step forward, you see the development ensues, but look at what happens to the PV. It's just kind of a straight line. It doesn't ever get cut off into a sort of a treble clef looking structure, and that prohibits the storm from ever really occluding. And watch the 1000 millibar isobar kind of bend toward this really cold but deep PV feature over New England. And if we keep going up, there it goes. It's trying to develop something on its own in association with that. So I want to just go one more time and let's see what the vertical structure looks like by tilting this up. Look at that. That's a stalactite of PV, that feature over New England that's coming down. And notice how it's tied to the coldest air at 700 millibars. And then this feature here is receding back to the stratosphere as the cyclone passes its peak intensity, and it cannot occlude because there's no wrapping up of the PV structure at upper levels. There's no chance of that happening. So just a few points of interest with respect to the busy Atlantic that we've seen at the end of this week. So I'm ready to stop sharing and turn it over to Michael if there are no questions or comments.
Okay, thank you, John.
Okay.
Let's see if this is going to work. And starting off with what you were just discussing, here's a cross section from 6 hours into the GFS forecast. Does that show up well?
Yeah, really nice.
Okay, so this is a cross section from the GFS forecast for valid at 18Z today. You can see the cross section was taken just south of the Carolinas and then into maritime Canada, location B on the right side of the screen. And this is really amazing. That upper trough that you were just looking at, the stalactite and PV, you can see the PV here in this cross section. Winds are the purple contours. Winds from the north are solid, or winds out of this cross section are solid. Winds into the cross section are the dashed contours. And you can see a really nice structure that goes all the way down to about 700 hectopascals. So this is a really deep PV structure. And again, it's one that's going to certainly have a chance to connect with features in the lower troposphere and instigate at least some pressure falls, height falls in the lower troposphere. So that's a really interesting structure.
Yeah.
We'll see how that evolves. And I think the cyclone that you looked at that has that T-bone type structure was something that, I like to look at forecasts that are, 200, 300 plus hours out. When it was 300 plus hours out, this was actually in the forecast. This was something that people were, it looked like it was going to be a big East Coast or Mid-Atlantic and Carolina snowstorm. And while they did get some snow there, it wasn't the, these big grand totals that people were expecting or the models were forecasting, but it did have this really intense cyclone that drifted, developed off the, as it moved across the Mid-Atlantic and then moved into the Atlantic and just continued moving east-southeast for a few days before eventually recurving to roughly the position it's in today. So it's really remarkable that there was some high level of predictability on a very intense cyclone out in the Western Atlantic, 300 some hours out. So yeah, interesting from a predictability standpoint. So what I want to focus on today is the upcoming weather event. Here's from the forecast office in Milwaukee. National Weather Service forecast office in Milwaukee has issued a winter storm watch for the southern parts of our state, and neighboring forecast offices have watches out for the northeastern part of Iowa, and certainly extends over a good portion of the Midwest, northern Illinois, and some of the eastern lake counties along the western shores of Lake Michigan in southeastern Wisconsin. So a winter storm watch, and one of the things to you may wonder about, first of all, for those of you that don't look at these on a regular basis, is what does it take for the Weather Service to issue a winter storm watch or ultimately a winter storm warning? And they have criteria on the accumulations of snow for a particular period of time. This is the 12-hour winter storm warning snowfall criteria. This is for a warning, for them to issue a warning. And first of all, it's kind of interesting that this varies geographically across the country. For a good swath of the country, you see this light blue color. It's basically anywhere from 6 to 7 inches in that 12-hour period, and that covers a wide range. But if you live in Florida, if you're getting half an inch to an inch, that's enough for them to issue a winter storm warning. And I'm sure John would be just as excited if he lived in Florida to see a winter storm warning down there as we are if we were under those sorts of experiencing that. In the Intermountain West, you can see these amounts get much higher, 10, 12 inches of snow in that same time period. So again, geographically, if you live in different parts of the country, you're going to have different situations when they issue winter storm watches and warnings. Another thing to also pay attention to or recognize is that sometimes, particularly at the beginning of a season, whether it's a watch or advisory, the Weather Service might be a little bit more generous in issuing something, even if it doesn't quite meet the criteria because of people not being used to the road conditions for that very first event. But when you get to the middle of the season, these are the criteria that they follow to issue that. So what's that based on? We're going to kind of go through this in a reverse order. Here is the sort of forecast plume from some of the short range forecast models that are run. You can see the collection of models, the WRF ARW, the NMMM model, the different suites of mesoscale models that are run by the Weather Service. And this is the forecast plume, the mean of this ensemble of forecasts. These are different models that have slightly different configurations, slightly different initial conditions. The mean for Madison at the airport is just a little over 5, maybe 5.3 inches of snow for the Madison area by the time this event is over. That's going to expected to start sometime late tomorrow afternoon. And we see the low end of this is about 3 inches, and the high end of this is approaching about 8 inches or so. And so we're going to dive a little bit into what's going on with this particular weather event to get a sense of the factors that are going to contribute to our seeing some snowfall. First thing I want to start off with, this hasn't yet updated for the 12Z run. This is from a 6Z run of the WRF model that Isaac Schlussy has put together. This is a map of the upper tropospheric potential vorticity, and that broad trough that we saw all over the western part of the United States that Professor Martin was talking about earlier. Let me go back in time. You can see that this is at 6Z this morning, this is at 12Z this morning, 18Z. It's come on shore, and very often underneath these broad upper troughs, if you look at a cross section through it, like the one that we saw off the East Coast today, the one that's over here just over off of New England, it's very cold beneath these upper troughs, so the static stability is weak, and that can fire up lots of convection and showers. And so very often, following the passage of these weather systems inland, behind it you can get some convective type precipitation that can arise because of instability. And so that's perhaps a reason for some of the precipitation that's over there. As this trough moves eastward, you can see it begins to get eroded in its structure. And that change in potential vorticity this is along an isentropic surface, it's around 310 Kelvin, as it crosses the Rocky Mountains, isn't due to it's very unlikely it's due to frictional effects. This is due to latent heat release that's redistributing the potential vorticity downstream of this particular upper trough. That indicates a lot of latent heating. That's going to lead to potential vorticity changes as you follow the upper trough as it moves eastward. But you can see the position of that upper trough as it approaches the upper Midwest, or the Great Lakes states, is one that's conducive for us to get some precipitation. The track of it is almost ideal, not quite ideal for us to get a significant snow event. So again, you can look at that animation as I'm sliding the slider on this very nicely. You can see the wrap that wraps up, but also the potential vorticity here is not conserved. So there's evidently a lot of latent heating. If in fact you were to look at precipitation associated with this, these are in 3-hour amounts. You can see that precip kind of following the path of the upper trough. And John, that might be, maybe it's just, these are more shower and not stratiform type precipitation. You were commenting on a lot of the precip is on the western side.
Yeah.
Of that, it might be this is more showery type, convective type precipitation as opposed to stratiform.
Yeah.
But what's kind of interesting to see, and we'll look at this when we look at other model forecasts, is how rapidly this precipitation area blossoms once you get sort of a flow off the Gulf of Mexico, contributing to flow into this particular event. You see this wide swath of pretty significant precipitation in 3-hour increments, 3-hour intervals of 1/4 inch to 1/2 inch of liquid precipitation just to our south. And some of this will obviously be frozen in the form of snow. And that's something that's going to be interesting tomorrow to see in the forecast as this evolves. So there you can see the formation of a cyclone in the lee of the Rocky Mountains as the upper trough moves eastward. It's centered over Kansas. And this is one that actually doesn't deepen considerably. We'll look at, again, the Gfs forecast and zoom in a little bit and see what that track looks like and what the accumulated precipitation looks like. Again, certainly if there are questions, please speak up. just another view. This is from the GFS. This is from the 12Z analysis this morning. This is from our AOS webpage, Pete's maps that he's created. And we can step through this and see, again, a very similar evolution of this upper trough. It's interesting is at 500 hectopascal, you see the heights in geopotential heights in white, and the color is the vorticity. Again, a really nice change in curvature as you go from the base of the trough over southeastern Oklahoma, cyclonically curved, to this anticyclonically curved flow that's over parts of Illinois and Indiana. In between those, right over Missouri, that's where you're going to get significant ascent occurring. That's where you probably expect some of the precipitation to break out just from that change in curvature, divergence being maximized downstream of the upper trough. But as we step forward, just 3 hours later,
boy, look at that.
Look at that. This is the still nice change in curvature, but I would, it's probably arguable that at least based on just this map alone, you might anticipate that most of the weather, if you will, the precipitation and vertical motion is going to be well to our south. I wouldn't think a structure like this would, you'd be seeing the main region of divergence extending much further to the north here. And we'll see when we look at some of the other elements. If we look at 850 millibars and the temperature structure there, a lot of the frontogenesis is also kind of focused to our south. And I think those coming together, these elements coming together, suggest why the Weather Service has the counties just to our immediate south as being the ones under the gun, as opposed to us being in that particular zone.
Michael, this is interesting. And Isaac's maps are great. So thanks, Isaac. Those are fantastic. Great work. This is interesting. This short time period that you went from 24-hour to 36-hour forecast. One sees the what I think is the recession of the upper of the tropopause back to its normal elevation. Mm-hmm. And that one of the things that could do it. It's not the only thing it could do it. Is you might have warm advection in cyclonic shear at the base of the trough. And so the isotherms have kind of oriented themselves in a way that still promotes ascent. In fact, the ascent's what recesses the tropopause back to where it belongs, but it's no longer kind of loading the gun for a subsequent development. And so it makes me think that, your comment about the frontogenesis being strong in the region of that little vortex strip across northern Illinois down into southern Ohio, that's going to be the whole rest of the game for the precipitation development. If you start to see the vortex at 500 millibars going back to a higher elevation, like it appears to be doing in this structure, there's no longer any cyclonic vorticity advection intensifying, and you got to rely on the lower tropospheric thermal structure and differential temperature advection to drive the vertical motion forcing, I think.
Right. And I think what you just mentioned, John, is really interesting about the sort of the tropopause kind of lifting back up. That was probably the same set of elements that were occurring out over the Atlantic with that initially deep tropopause, and you're in the southwesterly flow. It's kind of beginning to recede back up to the tome.
I think that's right. Yep. I think that's right. Yeah. It becomes less of an anomaly. That's what it is. Yep.
Okay.
So next map.
Can I ask a quick question before you move on?
Oh yeah, please, Benjamin.
I think it's related to the map you showed earlier regarding the thresholds for snow for the winter storm warnings, but in the lower right-hand corner of the screen, is this an updated or an older map? Because it looks different than the one you showed earlier.
Wait, which one? This one?
Yes.
Okay, yeah, so this is for the 24-hour criteria in terms of amounts, and this one is for 12-hour.
Oh, okay, makes sense.
Yeah. Okay, thanks. And also I thank Chris Smallcombe, who I had seen maps like this earlier in the few weeks ago, and I thought, oh, that might be a good thing to show today, and he was able to find that for me. So thanks, a alumnus of our program. Okay, so going back to the forecast maps, next, this is from the pivotal weather site, the pivotal site. We can sort of step through these. This map, this is the NAM forecast. I'll just use that as just a different view of this. Again, starting now. And as John said, you can see the warm advection beginning to sort of take over across parts of the Midwest, and we're finally getting into some warm advection. Still cold outside, you're not going to feel that, but temperatures are on average from 500 millibars down to 1,000 hectopascals, increasing as we have that warm advection.
Can I just say, Michael, it's not that cold. How many years ago will it be? It'll be 70 years ago tomorrow. We were minus 37 in Madison, all-time low.
Yeah,
so this isn't anything to complain about.
Right. Yeah, that's true. Fair point. This is not cold. We've seen colder, and we'll see in the forecast it'll get much colder. At least it's anticipated to get much colder. But when people hear the term warm advection, they might, that might warm their hearts, but no, you still want to bundle up outside. It's gonna be chilly. But you can see, and in fact, one of the things you look at, oh, wow, these 546 thickness, it must be warm. Remember, that's an average temperature. Look at the corresponding actual surface temperatures. We're still solidly, and we're in the upper 20s, which isn't bad. That's at least forecast for tomorrow afternoon, but which is certainly warmer than today. But I'd say it's still a bit chilly. But fair point. But here's what I found really interesting. If you watch this sequence of maps, this is 15Z, so this is 9 o'clock in the morning. Go to 18Z, it's like, when's the precip going to start? You see a little light precipitation just to our west and toward La Crosse, but very light, a little icing down in southeastern Iowa. And then just bang, it really, in my mind, really rapidly begins to fill in over this time interval. Okay, and you can see the formation of this nice, oops, didn't want to do that. That's not what I wanted to do just yet. But you just go back a couple time steps. This is also true in the GFS forecast as well. And so I was thinking, what's going on? I mean, obviously we have favorable conditions for ascent, at least from some of the elements that we looked at earlier. But if you do a sounding over southern Wisconsin, maybe between Madison and Janesville at this time, you'll see that the column is pretty close to saturated, particularly in the lower troposphere. And so just any ascent is going to help bring that temperature and dew point lines much closer together. You're going to get saturation quite rapidly after this. In fact, if you were to step ahead in time with this in the NAM forecast, you can see how quickly these collapse together to get really a fairly saturated. I think it's even better in as you get into tomorrow evening. You can see that, and also it's a pretty deep layer in the column that gets saturated. So the availability of moisture is not going to be an issue for us. Temperatures are certainly going to be cold enough, if you look at the soundings, for this to be all snow. Maybe a wet snow at the beginning, and some other points soundings that I looked at, you can see that it was still below freezing, but a little bit closer to freezing. I think that was in the GFS forecast. But then things begin to cool off. The entire column begins to cool off. So maybe a wet snow initially, and then it's going to become one that's a bit drier in nature. Oops, don't want to show that. So the next thing I wanted to look at was, we often click back and forth to look at maps. This is a feature that I hadn't really looked at, but in the last few days I've sort of begun using it as a tool to compare forecasts all valid at the same time from a different set of models. So this is a quick look at sort of an ensemble forecast, and we're going to go back to roughly the time that the precipitation is starting. This is the CFS model, which is a very coarse resolution global model that's run out to 768 hours, about a month out, but this is just the first 48 hours of it from last night's run. This is the Ecmwf forecast from last night. The 12Z run is not in yet. It is actually in. It is available. This is the 36-hour forecast for it. So you can see the snow beginning to move in roughly the same time. The GDPS, which I believe is a Canadian model, that's a little bit slower in the start time for the snowfall for us. GFS is pretty much like the Ecmwf with a fairly good slug of snow, the heaviest amounts still to our south. This is the GFS, the next version of the GFS, the FV3 model. This is from last night's run, which brings a heavier snow in. In fact, we'll look at snowfall amounts. This is one that was actually far wetter and whiter for us in the forecast. Here's the high resolution rapid refresh model. Again, all telling about the same story, that we're going to have snow in here, certainly by dark tomorrow evening. This is the NAM, the 3-kilometer NAM. But I think the other main message that comes from this is that, with the exception of this Canadian model, which is a short-range Canadian model, this is also a little bit slower. So it might be something with how they're initializing the data or during their analysis. Heaviest snow to our south at this point, but certainly in here by 0Z tomorrow evening. So again, these are all models valid at the same time, but they have different configurations. So it's a nice way to quickly evaluate similarities or differences in models. If we were to go ahead just a little bit further to midnight tomorrow night, so this would be early Sunday morning, same set of models. I wouldn't look at the CFS so much, but here's the Ecmwf, again from 12Z this morning. We're solidly in the snow. Also note the cyclone is now up to 1,000 hectopascals in this model. And the position is really well to our south. Okay, 998 in the earlier run of the GFS. This is the HER, has it just around 1,000, slightly below that. But I would say it's a pretty solid forecast for snow here into tomorrow night. And if we go ahead to Sunday morning, I'll go mid-morning Sunday by the time this should be wrapping up. Here's a collection of the models that are available for the same time period. The GFS has 1,002 low, so it's filled a little bit, well south of us, but that's not really the issue. It's really where it's the forcing for precipitation. Sort of disorganized, scattered light snow over the upper Midwest. Part of that's in that cyclonic envelope. The Ekman pumping, those of you in 453 this year, we remember talking about that last spring semester with frictional convergence in the boundary there. That's part of the reason you're getting some of that precip. But really light precipitation continuing during the day tomorrow, certainly into tomorrow morning. What about those grand totals for snowfall amounts on this? We look at let's look at, since this is the only game in town, at least through the first part of the forecast, let's look at through Sunday afternoon. Actually, I'll go to a time where we have a few more models available, and I will zoom in to our area so we can get a closer look at that. Okay. Ecmwf gives us about through Sunday morning. Again, we'll have some light snow occurring into maybe the late morning, early afternoon, but you can see about 4 inches, about 5.5 down in Janesville. The Canadian model GDPFS has that strip of really heavier snow well to our south, but it's at 3 inches. GFS about 5. This is the next version of the GFS that's being run experimental. It has us at 7.5.
Wow.
That's
the snow of the year if it happens.
Yeah, that's not going to happen. I say that without much confidence, but I think it's kind of an outlier at this point. Not that it's not going to happen, but I think it's unlikely. 3.1 in the HER. I think these solutions that have the heaviest snow to our south and most confined largely in northern Illinois are probably the more likely outcomes. 4.9 in the HER, 6.0 in the another version of the WRF model. NSSL's version 6.4. Then NAM is 4.5. The NAM 3 kilometer, interestingly enough, is at 7.1. So there's some spread in that, but it looks like it averages around 5 inches or so. And so that's probably a reasonable forecast. There's the UK Met at 4.5. So, maybe between 4 and 6 inches is probably going to be a reasonable forecast for this particular event. Now, what's really interesting in just a few minutes that are remaining, I just want to turn our attention to the East Coast for a moment, because this is really something that we haven't seen. I was commenting to John and Professor and Greg earlier about a scenario that we haven't seen in a while with respect to East Coast weather events. Many of you know I grew up in the Baltimore area and would often get excited back in in the late 70s and early 80s, well before most people that are on this Zoom can recall. We would get these what are called Miller type B cyclone events. And what these are cyclones that, like we're seeing in the forecast, track along through the upper Midwest, or the Midwest, excuse me, through Illinois, Indiana, and Ohio, and kind of begin to peter out, begin to fall apart. Part of this could be due to the fact that the upper tropospheric structure gets really wrapped up, and there's very little change in curvature through the flow to support significant divergence. Then you would see to the southeast of the event, over the Carolinas or over southeastern Virginia, a secondary cyclone beginning to form. Now, for the DC and Baltimore areas, you can see they're going to get a nice slug of snow early on Sunday, or Sunday night, excuse me. And then it looks like it's going to turn over to rain. And at this point, you might say, well, game over, right? Once it turns to rain in the east, this is the end of the event. This is 9Z on Monday. In fact, let's zoom in on this because I think this is really an interesting setup. Again, will it happen? This is in the forecast. We'll see. So you look at a forecast like that, if you lived in the DC area, Baltimore area, it's like, well, this is it. It's over. Game over.
Yep.
Cyclones, it's going to fall apart. Then, oops, watch what happens. We get this burst of heavy snow that begins to break out, in Ellicott City and just areas west of Baltimore. You can see the cyclone looks like it was beginning to head out to sea. There's this broad area of low pressure that still lingers right just off the Ocean City, Maryland area. And then you click again. This whole area is turning right back into snow, and the low gets even closer back to the coast as this main cyclone, the initial primary cyclone, has weakened. Still later, look at that. As moderate snow begins to spread into DC and Baltimore at this period of time. This is like event number 2 in the event. What you thought was an event that was over, and then it basically crosses from the western side of the Chesapeake Bay into eastern Maryland as the cyclone begins to deepen, and even areas up along the I-95 into southern New England begin to get a little bit of snow with this. How much do they get in that sort of second period of snow? Let's go 12 hours. This is just 12-hour accumulated from 12Z on Monday morning when it was just still rain and such. In that 12 hours, they got close to maybe 6 to 10 inches of snow in this broad range right here along the Chesapeake Bay.
That's pretty good.
And so what's really interesting about this is what are the features that are causing this so-called secondary development to occur. Okay, if we go back to, let's say, Sunday evening. At this point, you don't really see much. The cyclone is still back over Illinois. I'm gonna go a little bit closer. That's Saturday evening, excuse me, or Saturday evening. By Sunday morning, you can see it's in southern Illinois. You can see this sort of inverted trough-like structure that has begun to develop. There's certainly on the east side of the Appalachians. And then as you go further in time, you can see pressures are falling in this region. I mean, you still have a lot of cold air that's trapped up against the Appalachians. You can see hydrostatically right along the Appalachians, you see this ridge, and the thicknesses kind of indicate that there is cold air that's trapped there. And so that might be cold air that's stuck there. You have a nice baroclinic zone across the Carolinas. But then 1,002 low, a few hours later, it's still 1,002. Pressures are still falling here. Nice curvature in terms of geostrophic vorticity. Nice slug of geostrophic vorticity very close to the surface is formed. And the pressure is 1,008. Still in there. Now you have finally a closed contour that's occurred, that's located right here. Now maybe part of the pressure falls are that you have this broad cyclonic flow. It's crossing the Appalachians to the southeast. And one of the things you might say is going to be to the southeast of this low with a mountain range here, that's northwesterly flow across the mountains should lead to vortex stretching, right? You have air coming down the east slopes of the Appalachians. Maybe it's getting stretched. Maybe it's in a region where you do have favorable baroclinicity. And over here, there's stronger baroclinicity offshore. But this is just really an interesting evolution of an event. Oops, I didn't mean to go that far ahead in the forecast. But again, you got a really decent cyclone out of this as it develops. So something to watch for in the forecast over the East Coast if you're interested in sort of odd or not, I would say not well understood phenomena. That's something to look at with this. And I'll just quickly go ahead, advance in the forecast into early next week. Once that cyclone finally gets out of the way, we have another surge of warm advection occurring with a very similar sort of trough-like structure that hits the West Coast, moves inland. But this looks like it's going to have a slightly different track for us. We're going to get warm advection, but we'll actually truly warm up, I believe, into the 40s with this, and maybe even have some sort of squall line or convective line that eventually comes through during the day Thursday evening with some maybe some thunderstorms and strong warm advection. So that's going to be something to watch for later in the week. And then the real cold air comes back into the area. For Weather Watch next week, we'll be talking about that windy, cold, how cold. Again, we've seen colder. 23 degrees isn't something to whine about. But once you get into the following weekend, it's getting, this is at 0Z. So at 6 p.m. at 0 degrees, minus 0 degrees even, that's even worse.
Like the nexus of the thermometer scale.
Right. I think this is actually in an absolute temperature scale. No, it's going to get cold. It's going to be windy. And you can see the wind chill. So they're going to become a factor, if you will, pun intended.
Oh,
the wind chill's getting down. So that's going to get cold. That's
get the wind chill off there. Who cares?
You stand outside without a coat on. We'll see how that goes. But yeah, so colder weather coming back in for the early to a week after this. So after next weekend, it looks like it's going to get cold again for the start of February, the first full week of February.
Can I make a quick comment about the cold air?
Yeah, sure.
Well, I know on Wednesday morning, and I was looking at this a little bit yesterday, in northern Minnesota, it got as low as negative 35, and that was with a batch of cold air that was pretty mild compared to what I think we can agree this to be as more severe. So it'll be interesting to see how cold it does get in places like northern Minnesota next weekend.
Mm-hmm. Yeah, and there's going to be fresh snow cover, additional snow cover in that region as well because of the cyclone that tracks to our west in this forecast. So it'll be interesting to see how that actually ultimately works out for that.
That's really interesting. Benji, that's a good point too, that it could get worse. But the question that I have in the two questions, one is related to the secondary development. Was there anything at upper levels, Michael, that was a secondary, upper trough, or was this a type B cyclone or type A cyclone of Miller type B?
There was, it was the remnants of that upper trough as it crossed over the Appalachians. That upper trough was still there. Let me just share the screen really quickly. It's a good question, John. The upper trough, I think, was still a factor. I also saw in the chat, I missed just my forecast for snowfall is about 5.5 inches. Matt was asking that question. But the upper trough, if I can bring it up, dynamics. So here's the upper trough. Again, it looks pretty fierce at this point. It begins to kind of fade a bit in terms of the changing curvature. Gets stretched out a bit. You can see there's still actually, if you look at this, there's still a nice, ridge, pretty tight ridge there. The curvature of the base of this trough is a little bit weaker, but still probably decent region of divergence over Indiana and Ohio. And the trough does make it eastward, but it's less impressive. Even the ridge begins to kind of collapse a bit in terms of its initial structure. You can see how, the change from the base of the trough to the downstream ridge, it's modest, but there is still maybe some weak divergence associated with it.
Yeah.
So
it's interesting. It's not really strong and obvious that there's a second upper feature that's driving this secondary development. That's interesting.
Exactly. So, I think once you get into, if I get to Monday morning, you begin to see a new lobe begins to form, but I wonder if that's partly a reflection of what's going on in the lower troposphere.
Yeah, I don't know. That's interesting. Yeah, that's really cool. Okay, and then my second question or comment is that, we get to February 4th or 5th, and that's when we get our first time maybe touching -10 or -15 degrees. Boy, we don't have any time left in the season when you get to the 5th of February, it seems to me. I know it's still possible to get below zero like that again, but boy, it's rare. I don't know off the top of my head how many times we've had temperatures below -10 after February 5th. I would be surprised if it's more than a handful in the last 50 years, because the sun's up at 75 degrees north latitude, it's getting close to there, so it's just hard to make cold air anymore. So I wonder if we're going to see one spell of it all year, and it's this one coming up.
Right. Climatologically, the coldest week of the year, I think we've just passed through that.
Yeah.
Right. So we're definitely on the upswing. So, but which also means we're headed back toward next winter. So.
Can I make a couple comments?
Oh yeah, please, Greg. Yeah, please, Greg.
In terms of that secondary development off of Cape Hatteras, we had always thought years ago that was because the strong baroclinic zone and the potential energy associated with that due to the Gulf Stream right there, which is probably still the case. But now what it may be is maybe the intersection of an upper level PV anomaly moving across and through superposition, it connects with the warm water and the warmth below. So by superposition, it projects downward right there when it hits the Gulf Stream. So I'm guessing it has something to do with that. The same way that the storm of the century in '93 or whatever it was developed in the Gulf of Mexico for that same reason. The trough gets close enough, the PV anomaly aloft gets close enough, and then projects downward through superposition. That might be part of it. Also, as far as this year goes, I didn't chime in with much of this, but this is a very weird year. The polar vortex is pretty much gone. The polar night vortex, polar night jet vortex is gone. It's sitting over Asia, and I showed you guys a couple videos of that this week. And Asia seems to just keep getting warmer and warmer in the stratosphere for whatever reason. And so the whole upper level stratospheric jet that would normally be a circumpolar jet is sitting over Asia as a westerly jet, and then even easterly by the time you get to the pole. So there is no polar night jet. There's no there's nothing at the pole that's holding up the cold air there. So I think winter's going to end very soon, the way this looks. I don't see where we're holding very much cold air back at the poles. And most of these cold fronts that are coming through are not the penetrating surges of cold air that we typically see in the winter. They're just little surges that are almost like climatology oscillations, and no big push where you connect into this polar vortex. So anyway, my view is that this winter is very, very anomalous. I think it's the most anomalous I've seen in a decade or more.
A lot of people are saying that from a variety of perspectives, Greg, and it's interesting to hear you say that. I know we've been chatting kind of offline most of the winter, but I'm really intrigued about, is there a way that we can, at a certain point in the winter, can you make a reasonably confident forecast that the winter is almost over? And I think it involves lots of different things to look at, some of which are clearly connected to the polar vortex in the lower stratosphere, but then also some other things in the lower troposphere. It'd be really fun to try and figure that problem out and at least make a hedge. You know, what if we were right 60% of the time after a certain date, like January 20th or January 30th?
Yeah.
And I think there's a lot of commercial value to that in all kinds of different, applications. If you can figure out with a reasonable degree of confidence that the winter is either not over or is over at a certain point, date certain, boy, that means a lot for, retailers and various other industries.
Yep.
Right, but I think also the oddness of the winter, I wonder if that's related to what we were talking about just before Weather Watch began with these so-called secondary developments, right? We haven't seen those also apparently in quite a while. And I'm wondering, if you did a climatology of the Miller type Bs, would you actually see it related to some large scale flow patterns that have been recognized, NAO or Nina, La Nina. And the other thing, Greg, you're mentioning about this PV anomaly sort of superposing or interacting with something in the lower troposphere over the Gulf Stream. It seems like some of the initial development is in the form of a trough that's in the lee of the southern Appalachians that kind of creeps northward and eventually kind of closes off. So, that might be tied to baroclinicity onshore, and then kind of jumps even further out to the Gulf Stream once it's more readily developed or the upper trough crosses over. But it seems to be a predecessor.
There is this aspect of lee cyclogenesis, such as on the West Coast, you seldom ever see a storm just going across the Rockies. They always reform over Colorado or on the lee side, on the lee side, and that's because you don't see them through the normal reduction to sea level pressure and the ways we usually look at low level 1,000 millibar storms. You don't see them when they're over the Rockies, and the same thing may be true over the Appalachians, but to a lesser extent. That the storm doesn't really stop in Ohio. It just moves over the Rockies and disappears in Ohio and reforms in Virginia and the West Coast. That's the traditional way I've always thought of what's going on. But I don't know. Now I'm thinking the superposition has something to do with it too.
Mm-hmm.
And the concavity of the coastline is a factor, I think, to some extent too, because that changes the low-level divergence field a little bit.
That's what Bossart talks about. That's one of the ways he looks at the superposition. The concavity of the coastline in the Gulf of Mexico is how the superstorm was produced in that paper he wrote. And it's the same kind of a situation up there. The concavity forces convergence and works with the PV anomaly and superposition, the whole thing. So, yeah.
Well, thanks, Greg, for those comments. That's really interesting. I think the weirdness of this winter and maybe the signals that you're seeing that might indicate that this is going to be maybe relatively short winter are encouraging. I want to warm up, so I'll take it. And John would too, I'm sure, right?
Well, we do need a break. I will say yes. I'm going all in on an early end of the winter. Everybody needs to get out of this winter for a lot of reasons. Yep, I agree.
Yeah.
Okay. So John doesn't like snow. That's what he just said. We have that on the recording, right?
I feel like that was misinterpreted somehow.
Maybe even deliberately. Okay. Well, thank you, John. Thank you, Greg. Thank you, Pete.
Thank you, Michael, Greg, and Pete for organizing this, and we'll see everybody next week. Yeah, great.
Stay well.
Bye.
Michael.